Welcome back to Exploring the Spectrum. Today we have with us Dr. Lucina Uddin, who directs the Brain Connectivity and Cognition Laboratory in the Semel Institute of Neuroscience and Human Behavior at UCLA. Within a cognitive neuroscience framework, Dr. Uddin's research combines functional and structural neuroimaging to examine the organization of large-scale brain networks supporting the development of social cognition and executive function. Her current projects focus on understanding dynamic brain network interactions underlying cognitive inflexibility in neurodevelopmental conditions such as autism spectrum disorder. Thank you for joining us to share about your work.
Thanks. It's a pleasure to be here.
To start, I would love for you to share how you got into the work that you're doing and perhaps what drew you to this particular area.
Sure. Well, I think we all know what it's like to want to be able to flexibly adapt to situations, but to struggle with flexibility. I remember during 2020, at the start of COVID, we all had to kind of drastically change the way we go about our lives. And that was a big test, I think, for a lot of us. So even before that, I was interested in how the brain lets us flexibly, change our behaviors and the way we act in the world from moment to moment in response to things that need paying attention to. And it was always an interest of our lab for at least the last 10 years. And in particular, we were really curious about what's going on in the brains of children who are diagnosed with autism spectrum disorder, because oftentimes we do notice even more difficulties with flexibility in those who are diagnosed, making it, hard to adapt to changes. So, we've been interested in this question for a long time. Well, probably actually more than 20 years, but I'm just talking about the recent history now.
You mentioned COVID, that all of us had to kind of shift the way we do things. Mm-hmm. When it comes to cognitive flexibility, can you describe a little bit more what you're referring to? Just in general.
Yeah. More generally, it's sort of the ability to react and change your behaviors in response to changing circumstances, right? So, for example, if you are living in a city like New York, where you're used to taking the subway, and you wake up in the morning, they say, well, all the subways are down today. You're just not going to be able to do it. So at that point, it's, okay, what do? We flexibly come up with a different solution to the problem of how to get to work. So maybe we'll take an Uber, maybe we'll walk if it's not too far. Maybe we'll try to get the bus. But were sort of a standard everyday challenge we might have. I just had, I live in Hollywood, and Sunset Boulevard had a big sinkhole in it after a pipe burst last week. So I guess I wasn't going to be taking that path to work. So you could tell a lot of people struggle to flexibly adapt to the new routes because there was a lot of traffic. So I think we all kind of experience this on a day-to-day basis when something happens that's out of the ordinary, and you just have to switch what you're doing and what you're thinking to accommodate that.
And when it comes to autism spectrum disorders, we hear about this a lot, the rigidity in thought, behavior. So in your work, have you noticed any particular brain regions that are contributing to this increased rigidity in these populations?
Yeah, it's a great question, and it's what we and a lot of others have been trying to figure out. And it turns out it's not just one brain region, but a network of interconnected regions that together help you kind of flexibly adapt to situations and changes. And so they involve parts of the frontal lobe and parietal lobe, but also what we call the cingulate cortex and the interinsular cortex. There's kind of lots of different regions that they are connected to each other, and they interact in this really complex network. And so sometimes it's not just the brain regions themselves functioning differently, but also the interactions between them and how quickly you can bring them online, or how much sort of what we call dynamics, like how much can you switch between different networks in order to respond to the situation at hand. So what the field that I'm in now is kind of more broadly called network neuroscience, because we've been taking these more network type of approaches to try to understand brain function.
And I think that that's an interesting approach, because when I was reading a lot of the information on the neuroscience of autism, there would be 5 studies show that this area was affected, and the next paragraph would say, but the next 5 studies showed no correlation.
Exactly. Yeah, that's a good point, because when I started in this work about 20 years ago, there was all these theories. Like there was the amygdala theory of autism, that's the brain region we should focus on, or the cerebellum theory, that's the brain region. And it turns out, just like everything else, the brain is complicated, and it's never just kind of one region doing one thing, but a lot of areas acting in concert. And that sort of orchestration of the activity of different areas is what we're kind of focusing more now in psychiatry and in clinical studies.
You mentioned this network of regions. In your studies, are you noticing similar patterns amongst different individuals, or is it really like case by case, varying in the ways that all of our brains tend to vary?
Yeah, it's such a good question. I mean, because autism is so broad, you can have individuals with different symptoms. So yeah, it wouldn't be surprising if you would find subgroups of, some individuals who are affected in these networks and others affected in different systems of the brain. So that's actually a big part of the research push now, is to try to identify subgroups, try to figure out, what's the difference between this group of kids and that group of kids, whether they have an autism diagnosis or ADHD or something else. That it's oftentimes the case that it's not just one brain finding that explains the whole group. In fact, we're very far from that. We're actually trying to move more towards, what are the specific characteristics that show this particular brain pattern versus that one. And I think flexibility is an interesting way to get at brain differences, because you see it's not just affected in autism, right? Like you hear about OCD, for example. It's a great example of trying to do the same rigid behaviors over and over again. But the flexibility in OCD can be motivated for a different reason than the flexibility problems you see in autism. They could be a similar behavior, but coming about for a different reason, a different brain mechanism, a different thought pattern. So it gets even more complicated. Just because it's something about flexibility doesn't mean it involves necessarily the same systems.
Just in general, because cognitive flexibility, I imagine it's not static. It's going to change depending on environments or internal states. So what are some of the things that contribute to improved cognitive flexibility, perhaps in all populations?
Yeah, I mean, it's a great question. I think, a lot of people want to find, what's the answer. But as you know, my lab has been really studying the effects of being exposed to multiple languages, because that's actually one domain where you kind of have a natural experiment. Like some people speak one language, some people speak 2, and some people speak 3 or more. And if you're constantly switching between different modes of communication, your brain is doing extra work, right? It's keeping up with what was that word in Spanish? What was that word in English? Trying to translate. It's doing more work, and in that sense, maybe it's getting more of a workout, just like your muscles get more of a workout when you tax them more. So we have this hypothesis, and many others have proposed this before us, that having exposure or experience with multiple languages might make you more flexible, outside of language as well. It might make you more flexible in the real world, because your brain has gotten used to doing multiple things and switching and translating and constantly being challenged. So that's something that we've been really focused on lately in our studies of autism, is how does exposure and experience with multiple languages translate to greater flexible behaviors in the real world.
This is an interesting point, because I've heard it many times that professionals would recommend that you stick to one language to not confuse a child, that multiple languages will delay them in both. So can you share a little bit on the kind of the shift in that thinking?
Yeah, I mean, the beautiful thing about science is that we're constantly shifting our recommendations based on what we find. So I know in the beginning, maybe it was, prudent to be cautious and think, okay, if we're dealing with children with communication or language delays, maybe we'll just confuse them by speaking too many languages. So, that was the thought for many years. But now there's been a lot more research really studying families, studying cognitive abilities and language abilities in kids as they grow up in bilingual environments. And there just isn't any negative effect of being exposed to multiple languages. It turns out it doesn't hurt your development in different skills. It doesn't hurt your language development in the long run. You're just as fluent in both languages after several years of exposure. So it turns out it was kind of we were worried about something that didn't turn out to be a real concern. And so now, when I talk to parents of kids with autism, I'd say, yeah, go ahead, speak whatever languages you're speaking in the home. Not only is it, okay, it might even benefit them in ways that we're now just beginning to realize, like finding that they're better at executive functions than kids who are only exposed to one language. So yeah, the science is always evolving and we're trying to keep up.
In autism, there's also, parts of the conversation around executive function and being able to kind of navigate daily tasks. And then also social cognition, being able to interpret social cues. What, if any, benefits do you see across those areas in bilingual populations?
Yeah, I love this question. There was a graduate student of mine, Celia Robero, published a paper a couple of years ago where she found that kids who are diagnosed with autism and who are bilingual, they actually show better perspective taking skills. It's kind of like understanding what's going on in the mind of someone else. And that actually makes a little bit of sense if you think about when you speak to someone who speaks a different language, you realize they have different thoughts than you. They have a different way of seeing the world. And it helps you see things from a different perspective, not just the language, but the fact that, hey, this person interacts with the world differently and sees the world differently. So there was, her hypothesis that the sort of extra boost you get from being bilingual might carry over into the social functions as well. And so she did find some preliminary evidence for that. So it's kind of exciting because it's not like bilingualism is this, drug or anything like that. It's just something that can naturally happen in the home and can be really beneficial for those families who engage with multiple languages.
My thought process is like, okay, how do we get providers to know that this is something that we want people to be doing? Because there is so much concern. Even me, I was growing up bilingual. My parents would say, we were raising a Russian child in an American culture and not wanting to kind of steer too much in one way. And so I think for parents whose children do get a diagnosis, they want to know what's the best thing that I can do.
Yeah.
But the science oftentimes doesn't translate into clinics.
Exactly. Yeah, that's why I like to go out in the world and tell people, go ahead, learn all the languages, speak all the languages you would in the home. There's no reason to think it's going to negatively affect any of the outcomes. So far in the most recent group of studies, there's been no reason. If anything, I think there's a lot of cultural reasons why parents think, okay, we'll just speak English in the home. It'll be better for their education or things like that. Or, I think the reasons aren't really more about like learning and brain development, but more about like, will the kid fit in at school? If they speak with an accent. So I think those are some of the concerns that a lot of immigrant families have that keep them from really embracing their own language and culture. And it's kind of a shame, but I really hope studies like this can kind of convince people that bilingualism is a strength and multilingualism is a strength. And all over the world, outside of the US, I think it's much more common to be speaking multiple languages because if you're in Europe or Asia, you're pretty much constantly exposed to your own, native language as well as English, because English is a language that's spoken around the world. So you already have two languages, from the get-go. So it's not unusual at all in most cultures outside of the US to speak 2-3 languages. It's just something that we've been sort of late to the game in the US in terms of adopting.
Going back to what you were saying about improved perspective taking skills, are there any other social benefits that, because you said parents don't want to speak the native tongue because then being a teenager could be even harder, and these kids already struggle with, teenage years. Are there any other protective aspects of this that's coming out?
Yeah, I mean, we're just kind of starting to study this ourselves just for the last couple of years. So because we're mainly focused on the executive function associations or changes that are go along with bilingual exposure. So we haven't looked as much at the social cognition, but I do kind of suspect that the enhanced perspective taking, just being able to see the world in different ways. That it's also something that kids with autism can struggle with. So if there's a benefit that bilingualism can provide there, then it's kind of there's, to me, like no downside to being exposed to multiple languages at this point. There's no reason not to.
You mentioned executive functioning is something you're looking at more. What are some of the things you're seeing there that are improved in these populations?
Yeah, so things like inhibitory control, being able to stop doing something, or switching between tasks, like going from doing one thing to the other. We do see some sort of I guess enhanced abilities in those areas for the kids with autism, just in our preliminary study. So we're doing a much larger study now of 150 kids, and we're about we're just a year or two into it now. So we're really getting kids from all over Los Angeles who are exposed to multiple languages, and some are, of course, monolingual, speak one language at home, and some speak two or even more. And we're getting a full battery of tests. So we're getting, information about how fluent they are in multiple languages and different kinds of executive function. And we're getting all the brain imaging data, of course. And I didn't believe this when I first learned it, but like there are right now, no brain imaging studies that exist of kids with autism and that look specifically at how bilingualism affects their brain development. So we're doing the first study ever to look at that. And isn't that surprising that nobody has explored this yet?
Well, you can't patent bilingual.
Yeah, exactly. Maybe it's one of those things. It's not a drug. Nobody's going to make money off of this. But I think it's just a natural thing in the world to hear multiple languages, be exposed to them, to be curious about them. And it's a thing you can do even if you're not from another culture, right? You can encourage your kids to learn, Spanish, French, or whatever the school is offering. This is something that, it's an option for all parents.
I was shadowing my father in clinic one time, and he was assessing a child 3 years old, and the parents said that this kid, and the diagnosis was autism, but they said that he prefers to watch videos in Portuguese. Nobody speaks Portuguese.
How about that? Wow. Well, that's so interesting.
Yeah, no, maybe they're drawn to it as well. And like that's something that also, again, when we talk about clinical application of the things that are being studied, telling the parents, like, let them listen to another language, even if you can't speak it.
Yeah, there's certainly no harm. And that's the beauty of it. Well, what's the worst that can happen? They learn a few words in another language. I mean, it's something that, I've been kind of really interested in pushing more and more. I grew up with 2 languages because my parents immigrated from Bangladesh when I was young. And so it was just kind of, nothing unusual to speak multiple languages in the home. And when you grow up in California, there's Spanish. If you're in Florida, there's a lot of Spanish. So it's not an unusual thing at all, but it's, it's becoming something that, we're really excited about the brain imaging part, just to kind of be able to see like which connections maybe are being strengthened or which processes in the brain are being, bolstered by this. But no one has looked at it. So we're excited to find out.
You mentioned task switching and inhibitory control. Can you elaborate a little bit on this, just for context?
Yeah. I mean, inhibitory control is kind of the thing where, am I going to eat that donut or not? I guess am I going to, am I going to give in, or am I going to exert some, control and say, okay, I'm not going to do this. I'm going to do something else. And so that's something where, kids learn how to do that. But, really young kids, they're not inhibited about anything, right? They'll put everything in their mouth. They'll eat whatever's in front of them, and they'll say anything too. So it's something that we learn across childhood and adolescence. Like we learn how to control our impulses and control our, language and everything. So just it's sort of one of the broader rungs of executive function. We think of it as inhibitory control, as task switching, as well as basically, sometimes working memory. Like, can you remember something? How long can you remember it and hold it in your mind? So those are like 3 components of executive function that we can study them both together and independently with different tasks. And in our studies so far, we found improvements in inhibition and in task switching in the kids with autism who are raised in bilingual homes. But we're looking at kind of the full suite of different ways of assessing executive function. So we'll have a better handle on it later on. But yeah, the switching is more like, as we have to do all the time, kind of multitasking or essentially going between doing one thing and doing another. When you get interrupted, how quickly can you get back on task? That's sort of what this whole task switching literature is about. And people always say like, oh, I can multitask, but you actually can't do two things at once. You switch between doing one thing and doing the other. And when you switch between doing two things, there's this thing we call the switch cost, which is like, how long does it take you to get back to whatever you were doing? And so switch cost is a good measure of like how much task switching are you effectively doing versus you're just wasting time, essentially switching between different things and not getting anything done. So there's all kind of like these nuanced ways of teasing apart different executive function abilities. And those are some of the ways that scientists have come up with to look at different aspects of it.
The switch cost is interesting because we do hear this all the time, like the people are multitasking. How do you measure that?
Well, in the laboratory, we can come up with sort of ways of making you do a task and then making you do a different one. So like we have a task called the flexible item selection task. And you see a bunch of pictures. They're like rabbits and boats and other things. And you say, okay, pick two things that go together. And you'll say, okay, well, this rabbit is red and this boat is red. So they go together. And then you can give a different task with switches like, okay, pick two things that are both animals. And you can say, okay, well, there's this rabbit and this chicken. They're both animals. So you're kind of like switching the categories that you're grouping items by. So you're kind of flexibly switching between different tasks, essentially. And then so how long it takes you to like accurately do those things, you can measure when you're switching between color and shape or animal and something else. The switch cost is what happens when you're doing two different tasks, essentially, and going between them. Some people take much longer and some people can do it really quickly. And that's a kind of good measure of flexibility.
And for the subset that are autistic individuals, the cost is higher?
Yeah, exactly. So you can see disruptions in that process in kids with autism, but also across a lot of different conditions. Even like later in life when you get dementia, when you talk about that kind of the other end of the lifespan, you often see this switch cost or difficulties there as well. And that's another kind of really interesting thing about bilingualism is that folks who kind of speak multiple languages, they tend to, if they develop dementia, they tend to do it later in life. It's almost like the bilingualism protects them from the full effects of the dementia. These are sort of just observational studies, but there might be like a protective effect in terms of, keeping the brain more flexible for those people who have been speaking multiple languages their whole lives.
In terms of mental health, because if you have the switch cost and it's high, and then you're noticing that you're unable to do a certain thing that you used to be able to do much more easily, now you're going to tell yourself some kind of negative critical comment in your mind, and that creates its own loop.
Yeah, you can spiral. Yeah.
In terms of that spiraling, I've read how people with ADHD, they have so many more negative comments about their behavior by the time they're teenagers compared to a neurotypically developing kid. And that can affect your self-esteem, your sense of capability of what you're able to do. And I would imagine that this cognitive inflexibility can result in this negative cascade in mental health.
Yeah, I mean, definitely. One of the things, there's been some students in my lab who are more interested in depression, anxiety, and the development of those conditions. And one thing that I've always, made a point to notice is that you can have inflexible behavior, but you can also have inflexible thinking. So when you have depression, one big part of that is rumination, right? Thinking about the negative thought over and over and over again. And when you have anxiety, one aspect of that is thinking about the future in a negative way, like, oh, what if this bad thing happens? What if that bad thing happens? So like depression is like almost thinking negatively about the past, and anxiety is thinking negatively about the future. But they're both the same thing. They're repetitive negative thinking. They're thinking negative thoughts, whether it's about the past or the future. So it's like there's this like commonality with a lot of mental disorders that has to do with not being able to think flexibly, like get out of that loop, get out of the, tailspin of like, what if that bad thing happens? Oh, that bad thing already happened. Just getting out of that loop is I think something that when you have improved your skills and sort of flexibility more broadly, I think can help with that negative spiral as well.
What are some of the things that negatively affect cognitive flexibility, even in a neurotypical brain?
Yeah, I mean, it's a good question. Yeah, I think lack of sleep, stress, as you mentioned, is a big factor. All of the general things that are bad for your health more generally tend to be also bad for your mental health. So it's not sort of a secret or surprise that not getting enough sleep can mess with your functions, with your mental functions, and being under constant stress and high levels of cortisol running through your body, that can also interfere with your thought processes. So, yeah, it's nothing special or magical. It's all the same things.
And with individuals who, whether they're struggling socially or really sensitive nervous systems that we hear about a lot also in autism, you're in this constant state of stress. So cognitive flexibility is going to go down and then going back to that whole cascade.
That's right.
Is there anything else that, as you're studying this, has come up that you would maybe want to explore further? Anything, any signals coming up through the studies?
Yeah, I mean, I think part of it is how like you sort of feel a lot of things in your body, like when you have anxiety or any of these issues, like you feel it in your gut and like all throughout your whole system. So I'm really interested in finding new ways to integrate all these different bodily sensations. So it's like your heart rate is getting too fast, or your breathing is getting shallow, things like that are like part of your peripheral nervous system. I think we have to kind of start thinking of them all together when we talk about autism, anxiety, and all the other psychiatric labels that we have. It's not just your brain, but your whole body is experiencing whatever the condition is. And so try to like understand, where are those signals, being processed? How can we, that's why people do meditation and breathing exercises to alleviate, panic, right? Because the breathing itself regulates your body, which regulates your brain, and it's all linked. So some of the work we're doing that's actually outside of this area is about how the brain body signals are synchronized with each other. So your brain, your heart, your lungs, and even your gut, right? Everything is coordinated through one sort of integrated system. And so to me, studying just one piece of that is never going to be the answer. The brain is great, but like there's the rest of the body that it's integrated with to create this package that carries you around, right? So in my next phase of work, I'm hoping to come up with ways of getting more integrated whole body systems approaches to advancing psychiatry. That's my future goals.
I think when we compartmentalize everything, I mean, when I was in med school, they started teaching us systems-based medicine, which I thought was so progressive, but what it really did was it broke down cardiovascular system, gastrointestinal, and I'm like, that's actually the opposite of what you want. Doing.
Well, it's all one thing. At the end of the day, you experience, yourself in the world as a unitary being. And you can tell when something is wrong with your body, it affects your mental state and vice versa, right? So I think just ignoring that whole container is not going to make progress for us in the field.
And especially with autism, there's alexithymia, not being able to tell what you're feeling. There's changes in interoception. So sometimes they could be more sensitive or less sensitive. So it's almost like any intervention that can help individuals tune in more closely to their body signals would be very beneficial.
I love that you brought that up. I mean, this is exactly the kind of conversations that we're having now. It's like, well, we do we think about interventions. We think about drugs and chemicals that will help us, and often they do, but there's also what are the effects on the body, and maybe just there's other ways of affecting the body that can also be helpful for a lot of these mental health conditions. And I think we're getting there in terms of being more integrative in our thinking.
When you mention cognitive flexibility of switching between languages in line with what we were just talking about, it's interesting to me that, okay, the brain is there and it wants to help by assessing and creating a story about whatever's going on. And so sometimes that goes haywire with depression, anxiety.
Yeah.
And when people aren't used to feeling a feeling, I've started inviting them to recognize when their brain is coming up with this story, to give their brain something else to do, which is pay attention to the body feelings. So the brain still wants to help. So we're not just going to try to ignore all the thoughts, because that doesn't work.
Right.
But then giving the brain something else to focus on, like a template. Okay, what do my toes feel like? What do I feel in my heart? Just something that will ground a person in what's happening in the moment versus the stories that evolve.
I love that. That makes a lot of sense. I mean, it's interesting. If you see, I'm not a clinician, so I'm not seeing patients, but it's interesting sometimes when you make these recommendations that are they sound simple enough that they really change the way people experience whatever is happening to them. That's great.
It's usually the simplest things, and the tiniest little shift that if you could notice it happening, it makes you feel like you're maybe able to do a bigger shift. But I do oftentimes see people trying to take a leap towards their goal, and I'm like, that's not going to help anyone.
Baby steps. Yeah.
So anything else that you wish clinicians or parents would talk about or know about from the work that you and your colleagues have been doing?
Yeah, I mean, a lot of what we've been doing, I think, I'd love for people to just remember that we're still in the discovery phase of a lot of things. So, you mentioned earlier, not all the studies line up, and one study says this and one study says that. That's exactly the phase that we're at, and mainly it's because autism as a diagnosis has only been around, not even 40 years, I would say, but the first individual who was ever given this diagnosis just passed away recently. So it means within our lifetime, autism has become a thing that we study. And in terms of neuroimaging and understanding the brain, we've only been doing that really well for about 30 or 40 years. So we're all, basically still in the first phase. You and I are in this phase of, we know what autism is and we know there's something about the brain that we want to understand. But the next generation and the one after that will really make leaps and bounds in terms of discovery and finding out what's really going on and understanding the heterogeneity. We're just the first few people stumbling upon trying to understand the brain and psychiatric conditions. And long ago in history, people thought you were possessed by a demon or something if you had a mental health disorder. And so we're changing the way we think about psychosis. We're looking at the brain, we're looking at the body, but it's the discovery phase still. So I think some people get frustrated with the progress being so slow, but I think that's the way that science works. We learn from other labs and what's happening in other countries, and we collaborate, we work together. Well, we're getting better at it over the years, but we're still in the early stages.
And any words of encouragement for whether it's scientists or parents?
Yeah, I mean, part of it, we're doing studies now. Many of my colleagues are scanning brains and doing testing. And if you can participate in research, it's really helpful bringing your child in for a few hours to go through some testing and to look at their brain images and sort of contribute to the pool of data. The more we have, the more we can find these patterns, the more we can find what works as an intervention, and the more we can make more tailored treatments and, say, okay, this will work for your kid. It might not work for the next kid, but this is what we think works for this particular case. And so, the more you can sort of participate in research in whatever way, the faster we'll move along, I guess, in terms of discovery.
Where can people find you to either learn about the studies, to enroll, or just reach out to collaborate?
Yeah, I'm at University of California, Los Angeles, so I have a lab at UCLA, and it's pretty easy to find us just by looking up my last name, Uddin, at UCLA, where we have a website where we show some of our recent research projects and what happens when kids come in to get their brain scanned. They actually love seeing their own brain, so that's really fun. But yeah, we have more information about all our studies at our lab website, which is the Brain Connectivity and Cognition Lab at UCLA. And yeah, right now we're doing an ongoing study of bilingualism and its effects on brain development and executive function in kids with autism. So we're looking for folks who want to join.
And I will add all of these to the show notes. So
Great.
Thank you for the work that you're doing. Thank you for joining me on this podcast. And I hope that you get to explore those things that really inspire you.
Thank you so much. I'm so glad you're bringing this information into the world. Appreciate it.